Hello everyone. Welcome to version 2 of the practice exam. So looking at number 1, the classic true false. It's either you get all or nothing. So in number 1 we got it is possible for a system of linear equations of 3 variables to have exactly 2 solutions. So what does that even entail? We know for sure that a linear equation with 3 variables is no longer going to be a singular line, but rather like an entire plane, or we can imagine it as like an infinite sheet of paper. And so if this were to be true, that something has exactly 2 solutions, that tells us that if we have 3 planes, that they intersect only at 2 points. But that's impossible because the only possibilities are one solution, which is they all intersect at 1 point, no solution, they don't all intersect at one singular point, or infinite solutions, they intersect at infinite number of points. So this is impossible. Looking at number 2, we have the correlation coefficient of negative 0.9 represents a stronger linear relationship than 0.8. So whether a correlation coefficient is negative or positive doesn't have anything to do with if it is strong or not. A strong or the strongest correlations will always be when it is closest to either negative 1 or positive 1. And negative 0.9 is closer to negative 1 than 0.8 is closer to 1. So therefore, the answer for number 2 is true. Okay, looking at number 3, we have given a function f of x equals x squared, the graph of f of x minus m, where m is less than 0, shifts f of x up by m units. So let's see. So regardless, we know f of x, if we are subtracting m, that means we're influencing the outputs, the y values. So it's going to shift the graph either up and down. So that's okay. So let's just interpret what this even means. So if m is less than 0, in English that tells us that m itself is negative. So if m is negative and we substitute a negative number into this expression, then it's going to be plus a certain number. And if it's adding, then indeed it is shifting up. But does that even make sense? Well, shifting up by m units? Well, let's see. So once again, m itself is negative. So if we have a negative m, that makes it positive. So negative m is positive. Because to negate a negative number makes it positive. And so does it really make sense to say that we're shifting up by negative m units? Or like a negative number units? No. So we have to say instead that we are shifting up by negative m units, or we can also say absolute value of m units. Either one is perfectly fine, as long as whatever the expression is positive. So number 3 is bad. And we have number 4, the equation of the line that passes through the points a comma b and b comma b is y equals b. Well, let's see what this is even saying. So if we have 2 coordinates, let's just first identify what we see as objectively true. We can see that both of the outputs or the y values in both of these coordinates is b. So if we were to use the slope formula, well, we really don't need to, because the moment that we see that 2 coordinates share the same exact y value, that's going to be y equals b, or in other words, a horizontal line going through whatever b is. And so therefore, number 4 is true. Okay, move on. Number 2. So once again, we see a starred question, so we got to show work in order to earn full credit. And so this question is actually from the SAT, which is quite cheeky. So let's see what this is even saying. What is the value of 3x plus 4y given that the coordinate pair x comma y is a solution to the system of equations below? So when we see the system of equations, your inclination might be to, well, I want to solve it. And there's nothing wrong with that. But notice that the question is not asking for x or y, but specifically 3x plus 4y. So this is a kind of problem solving or creative thinking problem where we want to think to ourselves, how can we manipulate this system such that we create a 3x plus 4y? Well, it's kind of cheeky because, let's see. What happens when we add these 2 equations? Well, we're going to get 9x plus 12y is equal to 24. And is there any way that we can manipulate this equation to give us 3x plus 4y? Yup, by dividing by 3. So that tells us that 3x plus 4y is equal to 8, and that is our answer. No need to solve for x comma y. Just because we can solve for x and y doesn't mean that we should. We always have to keep in mind the goal of the problem, and we want to think to ourselves, what can we do to manipulate the problem in front of us to get that conclusion of 3x plus 4y? Okay, next, number 3. So number 3 is very similar to what we saw before, where we have a coordinate 21 comma 4 is on the graph of a function f of x, and we see that g of x is the result of transforming f of x in some sort of way. Now, before we start this problem, we have to realize that because there exists a coefficient in front of the x, that's a little bit problematic. So let's rewrite this function such that x itself has no coefficient, because that way we can accurately interpret the influence of each of these operations on the final graph. So here we have 4/7 times f of negative x minus 6 plus 5 as such. So all we're doing is just factoring out this negative, and if you're not sure why that works, is because when we distribute the negative to each term as such, then we get negative x plus 6, exactly what we wanted. So once again, we have to do this. We have to isolate the x, otherwise we will not be able to see the actual operations, the influence of each of these operations on f of x. So let's interpret each of them. So once again, anything that's within the input or the parentheses is always going to affect the x in some way. Even if the negative is not directly next to the x, because it's within the parentheses, we know it's affecting the inputs. So this minus 6, once again, we can't trust x, so it's going to be shifting to the right by 6 units. That negative is going to show us a reflection over the y-axis because we're negating the x values. Plus 5 tells us so these two values, because they're on the outside of the function, we're changing the outputs, or in other words, the y values. So therefore, 4/7, if we multiply a number by 4/7, the y values, that means, well, 4/7 is less than 1. So that tells us that it's going to be a vertical shrink by a scale factor of 4/7, because all the y values are going to be getting smaller and smaller. Therefore, kind of like a hydraulic press or like a sandwich. The graph is getting vertically smooshed. And then this plus 5 at the end tells us that we're going to be shifting up by 5 units. So once again, let's start off with our original coordinate, in this case 21 comma 4. And so once again, all the transformations that affect our x values will not affect our transformations on the y values. So we can do the operations all together as long as we do them in correct order. So once again, when we talk about transformations on our inputs, we always want to work with order of operations, or in other words, inside out. So we do whatever's inside the parentheses first and then negate. While influencing the y values, because we have 4/7 and plus 5, we have to work from left to right, so that tells us to do the 4/7 first and then the plus 5. So let's start. So shifting to the right 6 units tells us that we add 6 first to the values of x, and then to the y values, we first do the vertical shrink, which is multiplying by 4/7. And so, like I said in class before, I typically will not give you ugly fractions to work with. This was actually a mistake on my part, so even though the fraction will be ugly, let's just go with it. Okay, so right here, this gives us, what is this one? I had a brain fart. Oh, 27. 27, and then over here, this is going to give us 16 over 7. And so, just real quick, just ignore this typo right here. I'm going to fix it right now. Okay, 27. So after we add 6, then we're going to negate our values of x as such. And then over here, the 16 over 7, now we can finally apply the transformation of shifting up by 5 units, so we're going to add 5 to that. So therefore, our final answer should be negative 27, 51 over 7. And that is our final answer. Let's look at number 4. Number 4, they tell us that if the graph f of x equals absolute value of x plus 6. So you can totally put this on the graphing calculator, but by using what we know about transformations, this is an absolute value function, so that's going to be a v. And then this plus 6 is going to shift the graph up by 6 units. So it looks something like that. So in the question, they want us to stretch it vertically by a factor of 5. So remember, stretching vertically means that we're stretching it up and down, or in other words, the graph is kind of like getting skinnier as such. So that's what we want. So, well, once again, if we are stretching something vertically, that means that the y values are being changed. So therefore, we're going to have to multiply the values, or the y values, by 5. And so right off the bat, we can eliminate 3 and 4 because these are influencing the x values, not what we want. So now we're down to 1 and 2. So over here, we can see that the original is absolute value of x plus 6. So here we see that there's a multiplication of 5. But in answer number 2, they have multiplication of 5. And it seems that they also multiplied the 6 by 5 as well. So now the question becomes, well, which one is the correct one? You could totally put this into the graphing calculator and look at the graph, but that's going to kill too much time. So in this case, the answer is just going to be answer choice number 1. Because all we're trying to do is to stretch vertically by a factor of 5. So as such, we're making the graph skinnier and skinnier. But that doesn't change this, this point right here, which in this case is going to be 6. 0, 6. If we did multiply the 6 by the 5, that will make the graph both vertically shrink and shift up as well. And that's not what we want. We only want, vertically stretch. We only want to vertically stretch it and not shift it up even more. So that's why we have answer choice number 1. Looking at number 5. Number 5 looks scary, but again, it's all about perspective. So they give us these two graphs on the side, g of x and f of x, and they say to express g of x as an equation in terms of f of x. So what that's saying in English is, how can we manipulate f of x so it looks like the graph of g of x? So I'm just going to do a couple of things real quick. So what we can do is just make some visual observations. So looking at f of x, which is the red one right here, the black one. This one right here, that's f of x. And then we have g of x in pink. And we see that it kind of looks like it's getting skinnier, or it's like being stretched as such. So if it's being stretched, then we know for sure that it's going to be a change in the y values. But instead of just randomly guessing, let's just observe the change in the coordinates. So let's look at the change in their corresponding coordinates as such. Cool? So let's see. So looking at these 2 points, for example, the original would be 4, 2, and then in g of x it becomes 4, 6. So far we see that the x values stay the same, and then the y values seem to be multiplying by 3. Let's see if that's true for the other ones. Let's look at these 2 points. In the original we have 1, 3, but in the new one for g of x we have 1, 9. It seems like it's true so far. And if you want to, you're more than welcome to test it for the other coordinates as well. For example, negative 1, 1, then becomes negative 1, 3. Or even this one, negative 4, 2 becomes negative 4, 6. Exactly what we seem to have guessed. So therefore, it seems that all the y values of f of x are being multiplied by 3. Now, how do we express that then? So once again, g of x is a result of taking f of x and multiplying by 3. Because once again, f of x is synonymous with the y values, or the outputs. So this is just saying that we're multiplying all the outputs of f of x by 3, and that gives us g of x. Yay. Okay, 5b. So here they ask us to find the range of g of x, which again is the pink one right here. And so range, once again, is all possible outputs or y values. Where does the graph span from down to up? So we want to find the lowest point or the lowest y value for g of x. In this case, that's negative 6 right here. And we say that the graph continues up and up and up, and it ends at y equals 9 as such. So these are all possible y values. And so once again, we can either write this using interval notation or inequality notation. Either one is perfectly fine. But using interval notation, once again, we always have to write everything from least to greatest. So it's going to be from -6 in brackets to 9 in brackets as well. So we have to remember that brackets itself just tells us that that point does exist. There is a point when y equals -6, and there is a point when y equals 9. Same thing for inequality notation. We have -6 less than or equal to y less than or equal to 9. Now, if instead of y you write g of x, that's perfectly fine too, since they're both synonymous. Let's look at the next question. All right, looking at number 6. This right here is actually also another SAT question. So here we have, in a system of equations below, k is a constant and x and y are variables. Find the value of k where the system of equations will have no solution. So this looks kind of complex because unlike a traditional system of equations, we can't just directly solve. They're asking us to find the value of k that will make the system have no solution. So whenever we see these types of problems, we always have to go back to the root of what does that even mean? What does that even mean to have no solutions? So no solutions means that graphically the lines are parallel. So if the lines are parallel, that means that they have the same slope, but they have to have different y-intercepts. Because the moment that they have the same y-intercept, they're going to be the same line, or in other words, infinite solutions. So let's first start off with using the second equation, because that will allow us to find out what the slope is, since both of these equations should have the same slope. So taking the first equation, we have 4x minus 5y is equal to 7, and let's rewrite this into slope-intercept form by isolating the value of y. So we're going to subtract 4x on both sides, giving us -5y is equal to -4x plus 7. And then dividing both sides by -5 gives us y equals +4/5 x minus 7 over 5. So once again, going back to what we just said before, we need to make sure that both of these lines or both of these equations have the same slope and different y-intercept. So we know for sure that the slope should be, not that, should be 4/5. Okay. So now we can manipulate this other equation to find the value of k. So let's see. So once again, let's rewrite this into slope-intercept form. So we're gonna, well, you don't necessarily have to do it this way, but this is like an alternate way of approaching it. Instead of subtracting k over x on both sides, we can also add 3y on both sides, and then eventually subtract 4 on both sides. So these are just two different methods of approaching how to isolate y, but either one is perfectly fine. And then so from here we have kx minus 5 is equal to 3y, and isolating y, dividing 3 on both sides gives us y equals k over 3 times x minus 4/3. And so from here, once again, we want the slopes to be the same, and we want the y-intercepts to be different. And at this point, well, are they different? Yup, they are different, so that's cool. So now to find the value of k, that forces k over 3 and 4/5 to be equal to each other as such. So now we just got to find what value of k will make this proportion true, but instead of cross-multiplying, there's nothing wrong with just eliminating this 3. And because this is k divided by 3, the inverse would be to multiply both sides by 3, hence eliminating our denominator, giving us k equals 12 over 5, and that is our answer. Let's look at number 7. So number 7, the table below shows the number of math classes missed during a school year for 9 students and their final exam scores. So it says, write an equation g of m for the line of best fit for this data set. Round all values to the nearest hundredth. So sometimes the questions won't explicitly say find the equation of the linear regression, and sometimes they might just say find the line of best fit. Either way, we know that we should have to do linear regression. And once again, in this case, we have to follow what the question says. We have to write g of m instead of y, and instead of x, we write m, because those are the variables given to us. So on the calculator, alright, so let's look at number 7 on our exam. So here we have to use linear regression, and so once again we go to stat, and then edit. And so once again, if we have numbers already in our columns, we just highlight L1 and L2 using our arrow button, so L1, and press clear, enter. And we can do the same for L2. Clear, enter. And so we're going to type in all of our inputs, or in other words, the number of classes missed into L1, and then the final exam scores into L2. So let's do that. So you can either use the arrow buttons to move on to the next numbers, or just press enter after each input. So once again, even though this part is fairly straightforward, we have to be very careful with the way that we input our values. Otherwise, one wrong number screws up the entire answer. So you can either double check your numbers or just slowly input your values as you go, but not too slow to the point where you don't have time for the other questions on the test. This is take too long to do on a computer. Alright, cool beans. Okay, so once we have that down, then we go to stat, and then use the arrow button in order to get to calc over here. So calc, and then once again we can either use option 4 or option 8 as long as we substitute our values of a and b into whatever equation is given to us correctly. So I'm just going to do 4, and then press enter, 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 and boom. So as long as we substitute our values of a and our values of b into the first equation onto that is given on our calculator, then we'll be perfectly fine. Here we should have g of m equals negative 2.89 m plus 97.55. And so it says state the correlation coefficient of the data to the nearest hundredth, or in other words, r is negative 0.97. And to explain what it means in the context of the problem, once again, we got two options. We can either say that there is a strong negative correlation between the number of classes missed and the final exam score, or we can also say that as the number of classes missed increases, the final exam score decreases. Okay, moving on to number 8. So number 8, Miss Pan is given a set amount of paper at the beginning of each month to print worksheets for her students. The data table to the right represents the number of sheets of paper she has, P of X. So that tells us P of X is the number of sheets of paper in terms of the number of days that she prints, X. So that's what we know. X represents days, and P of X is how much paper is left. So in 8a, they ask us to write a linear function, P of X, that represents the data. So it doesn't say to write it in slope-intercept form or point-slope form, but again, I'm just going to choose to write it in slope-intercept form since 8b and 8c asks to interpret slope and y-intercept anyways. Alright, so we need the slope and the y-intercept. Now, we can totally just choose any two of these points and use the slope formula to find the slope, but we just have to remember, in reality, slope formula is just finding change in y over change in x. So looking at the table from 2 to 5, we increase by 3, while from these two values, we are decreasing by 780. Even for the other two values, from 5 to 7, we're increasing by 2, but from these two values, we are decreasing by 420. So you might be thinking to yourself, well, what is even the point of this? Well, what this does for us is that it simplifies things a lot more for us. Because once again, slope is change in y over change in x. So to find the slope, we can use the table. So change in y, the change in P of x over the change in x. And regardless of whichever two coordinates that you choose, the slope should be the same. In this case, negative 260. So we're done with the slope part. Now we got to find y-intercept. Now to find the y-intercept, there's two ways to do it. We can do it using slope-intercept form or point-slope form. So I'm going to first start off by doing What was I saying? By doing slope-intercept form, because some of y'all might be more comfortable with this. So once again, our equation is in terms of p of x, hence why I'm writing p of x instead of y equals. And this is the slope that we know so far. And what we want to find is the y-intercept, in this case, b. So what we can do to find the y-intercept is just to choose a random point to substitute into the equation. And I'm just going to choose this point right here because it has a lot of zeros. So substituting 5 comma 3,200 gives us 3,200 equals negative 260 times 5 plus b. And then solving for b gives us b equals 4,500. So that is going to be our y-intercept. So that's one way to do it. Another way to do it is using point-slope form. And if you forgot, point-slope form is just slope formula in disguise. So here we have our slope. And let's substitute in a random point. I'm going to use the same point. 5 and 3,200. And if you choose to use point-slope form, you can distribute the negative 260 to each term within the parentheses, giving us what we have here. And then isolating y gives us our final equation. So regardless of whatever method that you choose, our final answer or our final equation should be in terms of p of x, since that's what they ask us to find. So p of x equals negative 260x plus 4,500. Alright, so let's interpret what this means in English then. So slope, we know, is going to be negative 260, and the y-intercept is 4,500. So slope is, well, is a rate of change, so we have to explain what this is even saying. What does this 260 mean? So if x is the number of days, this is saying that negative 260 times the number of days plus this number will give us the amount of paper left. So we can think about it as such. Slope tells us that Miss Pan is using, because it's negative, I'm using 260 sheets of paper per day per x. Now next one, y-intercept. Definition of y-intercept is when x is 0. So when x is 0, that means 0 days has passed, or in other words, our initial value. So y-intercept tells us how much paper Miss Pan initially has or starts off with. So let's break this down in English. This is saying that Miss Pan is starting the month with 4,500 sheets of paper, and every day she is losing 260 sheets of paper. That's what it's saying. Let's look at 8c. So 8c says find p of 12. What's I saying? Oh, find p of 12 and interpret the result in the context of the problem. So once again, here we see inside the parentheses is this 12. So that tells us because our equation is in the format of p of x, whatever is inside the parentheses is going to be our value of x. So I'm just copying down the original equation. So to find p of 12, that tells us that everywhere we see x, we substitute a 12. And so solving that gives us p of 12 is going to be 1,380. Now, what does that mean in English? That tells us, well, what is the 12? The 12 is the number of days. So after 12 days, Ms. Pan will have 1,380 sheets of paper left. Let's look at 8D. Find the x-intercept of this function and interpret the result in the context of the problem. So x-intercept by definition is when y is equal to 0, or in this case when p of x is equal to 0. So taking our equation now, we're going to set the entirety of p of x equal to 0 because our goal is to find the value of x, the x-intercept. So to do that, we can add 260x on both sides in case you don't like dealing with negatives. And then that gives us x is equal to 17.3. So in English, what does that mean? So that means after 17.3 days, Miss Pan will have no paper. Yay. I know it doesn't really make sense to say 0.3 days, but the question didn't ask us to round, so let's just leave it as it is. Number 9. Okay, number 9 looks kind of crazy, but if we understand what the problem is asking for, it's not that bad. So number 9 says, given a function y equals f of x minus 7 plus 6. I just realized that this is not really a sentence, so it shouldn't have a period. but anyways, if g of x equals 3/5 times f of negative 6x plus 18 minus 15, describe the transformations performed on the graph of f of x minus 7 plus 6 to form the graph of g of x. Okay, y'all. In simple English, it's saying, how do we go from this equation, this function, to this function? That's all it's saying. So we just have to identify what operations do we need to do to this function to create this function below as such. Now, before we start considering anything, the moment that we see that x itself has a coefficient that is not 1, that means we have to use some sort of factoring. So to rewrite g of x, we have g of x equals the 3/5 doesn't change. 3/5 times f of negative 6 times x minus 3 minus 15 as such. So once again, the reason why we're doing this is so that way we can truly identify the real transformations that are happening to the original graph as such. So again, if you're not sure how we got this, if you distributed negative 6 to each term, that's going to give us negative 6x plus 18. Okay, so now we got to think, how do we go from this expression right here to this expression as such? So the first thing that we can notice is that there is no coefficient or multiplication in front of the f of x, so that's our first thing. So that's what I'm going to do in color as such, right? And then the other thing that this original function doesn't have is this minus 6. So that's also going to be inputted as such. And so now we got to ask ourselves, how do we go from x minus 7 to x minus 3? Well, let's see. So from x minus 7, what do we have to do to get x minus 3? We have to add 4, because negative 7 plus 4 gives us negative 3, exactly what we want. And then the last move, same idea. If the original is plus 6, we want to think, how do we go from plus 6 to minus 15? And that's going to be a minus 21 as such. So in other words, once we simplify, so notice very carefully, everything in black is the original function right here. And everything that we put in color are the operations that are performed to get g of x over here. So now once we have that identified, now we just have to explain what each of these operations means in English. So this plus 4, that's what's changing. So plus 4, because it's inside the parentheses, inside the input, that tells us that we're shifting to the left by 4 units. And then now let's talk about this negative and the 6. So the negative, once again, because it's inside the input as such, we can say that it is negating the x values, and when we negate the x values, that is going to give us a reflection over the y-axis. Over here, the 6, so once again, because it's influencing x, we can't trust it, so it's going to be the reciprocal of what we think that it is. So this is going to be technically multiplication by 1/6, or in other words, a horizontal shrink by a scale factor of 1/6. Because if it's the reciprocal of 6, which is 1/6, multiplying something by 1/6 makes it smaller, hence why it's called a horizontal shrink. And horizontal because if we're influencing the x values, it's left and right. And then lastly, we have our two operations on the outside, 3/5 and this negative 21. So that's influencing the outputs, or in other words, the y values. So that will give us 3/5 is a vertical shrink by a scale factor of 3/5, because multiplying a number by something smaller than 1 makes it smaller, hence why it's a shrink. And then we have our last one, minus 21. That's going to be a shift down of 21 units. So that concludes this question number 9. Alright, let's look at number 10. So number 10, it says to algebraically solve the system below. So once again, we have the choice of either doing elimination or substitution. I'm personally going to choose substitution. No, I am not going to choose substitution. I'm choosing elimination. And so, same idea. We want to eliminate a singular variable to create a system of 2 variables. I don't know what that sound is, but I think it might be construction outside, so sorry. Okay, so let's see our coefficients of each of our variables. This one so far looks ugly. This one also looks ugly. Now z, still kind of ugly, but 6 and 9 both share a factor of 3. So maybe there is some way to manipulate the 9 so that it eventually becomes the 6. And so let's see, is it possible? Well, even though we didn't talk about this in class, you're more than welcome to do this on the test. If we look very carefully at our second equation, notice that all terms are divisible by 3. 6, -9, -9, and 24, we can all divide that by 3. So why not divide to make it smaller? So let's try that. So let's just choose to eliminate z then. And so unlike in the other version of the test, we can't just change all of the equations at once to create additive inverses. So let's do this together. So let's first see these two values. We already see that these two are additive inverses, so let's combine the first and the third equation. And so doing so, that gives us negative 4x plus y is equal to negative 15. And so from here, the second equation, because z is already negative, and we have z as positive here, now let's try to manipulate this equation such that we create a negative 6z. So I'm going to show that work on the side as such. So like mentioned before, we can divide each term by 3, and that gives us 2x minus 3y minus 3z is equal to 8. And then to create a negative 6z, we can multiply everything by 2 on both sides of the equation, hence giving us 4x minus 6y minus 6z is equal to 16. So that equation that we just created is equivalent to the second equation as such. So combining the second and the third equation, that will give us 5x minus 13y is equal to 7. And so from here we have just created a system of two variables. Yay! Two equations and two variables. And that's going to allow us to solve for x and y. So once again, you can choose to eliminate or substitute whatever you want. You can either eliminate x, eliminate y, whatever you want. Here, I'm just going to choose to, choose to eliminate y because I only have to multiply the one equation instead of two. So multiplying both sides of the first equation by 13, and again, we want to do this to create additive inverses of positive 13y and negative 13y, such that when we combine the two equations, it goes capiche. I don't even know if I used that correctly, but whatever. So solving for x, we have negative 47x is equal to negative 188. Dividing both sides by negative 47 gives us x is equal to 4. And once again, because we have x, now we can solve for y. And we can choose either of the two equations to use. I'm going to use the first one because it looks easier. So we have negative 4 times 4 plus y is equal to negative 15. And solving for y gives us y equals 1. And at this point, the moment that we have two variables, we can finally finish the question by finding z. And so we can choose one of the original equations that we have in the problem to find the value of z. You can use whatever you want. I am going to use the last one because no reason, just because. So after substitution, we have 4 minus 7 times 1 plus 6z is equal to negative 9. Then we have 4 minus 7 plus 6z is equal to negative 9. And then continuing, giving us z is equal to negative 1. And that concludes our question right here. We can, again, write our solution by listing out all the numbers as such, or we can write it as an order triple. Either one is perfectly fine. And so that concludes this video as well. I know I went a little bit faster for this one, but it's because I assumed that you watched the first one. And I will see you